Hello everyone, welcome back to the channel. Today we'll be starting a new chapter called Introduction to Trigonometry. This is from class 10 NCERT Mathematics chapter number 8. Some of you may be able to understand that trigonometry is not a simple chapter, it may be difficult, but here we are going to learn that this chapter will be a very simple one. So we are going to learn this chapter in 4 different topics. Introduction, trigonometric ratios of some specific angles, and trigonometric identities. These are the 4 topics that we are going to learn. So trigonometry is going to be your companion not in just class 10 but even in your higher studies in mathematics, physics and engineering. So let's see what we can learn from this chapter. The first one is introduction. So what is basically trigonometry all about? When we look at the word trigonometry, we are able to find out 3 words: trigonometry. Tri means 3, gono means angle, and metry means measurement. Now what is this 3 and angle together called? Any guess? It's none other than triangle. Triangle is a polygon with 3 sides. For example, you can see a triangle here which is drawn over here. It is a simple closed figure with 3 sides. This is what we call as a triangle. So when we have measurements related to triangles, this is what we can learn from this chapter, which is called trigonometry. Basically, trigonometry is all about finding the relation between the different sides of a triangle and different angles of the triangle. You will be able to get to know the relation between the sides and angles of the triangle. You may think that you might have already studied about triangles in geometry chapters in your earlier classes. So is there anything that is new that we'll be learning in trigonometry? Yes, of course we are going to learn, but trigonometry is going to take you to the next level. Instead of finding just areas and perimeters, we'll now explore the relationships between the sides and angles, as we have already heard about. So what are the applications of trigonometry? So trigonometry helps us to find out the heights of buildings, calculating distance across rivers. So when we have a river, we have got 2 banks, we'll be able to calculate the distance between the 2 banks without even traveling. We can also understand wave patterns in physics. So what are wave patterns? All this we'll be able to understand, and not only that, we'll be also able to understand more about navigation and astronomy. Pretty cool, right? So let us see more on this chapter. We are just going to learn about right angled triangles. As we have seen from this chapter, trigonometry is all about triangles. In this chapter, we are just going to deal only about right angle triangle. So what are these right angle triangles? What is a right angle triangle basically? Shortly called as a RAT. I'll take the triangle ABC, where the angle B here is given as 90 degree. When you measure angle B using a protractor, you'll be able to get 90 degree, and whatever the triangle in which one angle of the triangle is exactly 90 degrees, such type of triangle is what we call a right angle triangle. Let us see some specialities of right angle triangles. We have got one right angle as angle B, and angle A and angle C are acute angles. And not only angle A and angle C are acute angles, they are also complementary angles. So what are complementary angles? When we have 2 angles whose sum is equal to 90 degrees, they are called complementary angles. For example, 20 degree plus 70 degree gives us 90 degrees. So 20 and 70 will be called as complementary angles. Suppose angle A is equal to 20 degrees. Then angle C must be 70 degrees. They are not only acute angles but also a pair of complementary angles. So this is going to be of great use when we are solving problems in right angle triangles. What else does a right angle triangle have? As usual, like other triangles, a right angle triangle also has three sides, but there are special names given to these three sides. AB and BC are called legs. So these two sides, AB and BC, are called as the legs of the right angle triangle. These are the two sides which contain the right angle, the 90 degree, and we see that the other side AC has a special name called as the hypotenuse of the right angle triangle ABC. Hypotenuse of this triangle. So hypotenuse is the name given for a side of a right angle triangle, the side which is opposite to the right angle vertex. B is the right angled vertex, so AC is what we call as the hypotenuse. So in this given triangle, this side will be the hypotenuse. Also, you will be able to notice that hypotenuse is the longest side of the right angle triangle. Whatever may be the right angle triangle that you can take, the hypotenuse side will be the longest side. Anything else in right angle triangle? We have got a very important theorem called as the Pythagoras theorem. Pythagoras theorem states as follows: in a right angle triangle, the square of the hypotenuse equals the sum of the squares of the other two sides. Given here the triangle ABC, I can apply Pythagoras theorem to show you what this theorem actually tells us. So when we have AB square and BC square added, you will get the square of the third side, which is AC square. AC is the hypotenuse. The square of the hypotenuse of a right angle triangle equals the sum of the squares of the other two sides, and this statement is what we call as Pythagoras theorem. This Pythagoras theorem is also so helpful in this chapter of trigonometry. And now this is very important here, that we have these two sides which we'll be learning as opposite and adjacent sides. As we are going to learn the ratios, we'll be able to learn the different sides of the right angle triangle with different names. Now let us move on to the 6 different trigonometric ratios. So this comes to the main part of this chapter, trigonometric ratios. What are trigonometric ratios? We have got 6 trigonometric ratios. Let us first carefully go through the 3 ratios, the 3 most basic ratios: sine, cosine and tangent, shortly called as sine, cos or tan. Now these ratios mean that these 3 are functions. Function in the sense all of these needs some value to get calculated. For example, if it is sine of 40 degrees, each of these needs an angle to get the value. Sine of 40 degrees, cosine of 20 degrees, tangent of 30 degrees, for example. So when it is 40 degrees, the sine is a function actually, and this function gives us a particular value. And since we are saying them as ratios, they are ratios of what? Now basically when we take the 3 trigonometric ratios, sine, we'll take the angle to be theta. So sine theta, cos theta, tan theta. These 3 trigonometric ratios. So sine theta is given by opposite divided by hypotenuse side. Cos theta is given by adjacent side divided by hypotenuse side. And tan theta is given by opposite side divided by adjacent side. Now wait, what are these opposite, adjacent and hypotenuse? You might have heard about hypotenuse recently. just few minutes before. And what are these opposite and adjacent sides? Let us take a right angle triangle. We'll take any variables a, b and c, and we'll just mark one of the acute angles, either a and c, as theta. So I'm just going to mark angle c as theta. So I can say this as sine theta or sine c, where c is the angle, theta is the angle of angle c. Now what is this opposite, hypotenuse and adjacent? So opposite to the C vertex, we have the side AB. This is what we call as the opposite side, and the remaining side we'll call as the adjacent side. As we all know, the hypotenuse is AC. Now opposite and adjacent, you may have a question whether they can interchange or not. Now if I just try to give a different angle, so here I'll take it as alpha. Now A is alpha, so this side will be the opposite side and this side will be the adjacent side. Now corresponding colors of the angles, I have written which side will be opposite, which side will be adjacent. Now generally for any acute angle that we take on a right angle triangle, the side which is not touching this given angle is usually called as the opposite side. So there could be only one opposite side for any of the angles that is marked. So for theta here, AB is the opposite side, and for alpha here, BC is the opposite side. So according to the opposite side that we fix, the remaining side will be considered as the adjacent side, where that adjacent side always will touch the corresponding angle that we denote. Whereas the hypotenuse always remain the same for whatever may be the right angle triangle that we take. Now you may have to think whether these formulae are simple or not. So we have a small word for us to understand, a small word like this, SOHCAHTOA, SOHCAHTOA. So sine is opposite by hypotenuse, cos is adjacent by hypotenuse, and tan is opposite by adjacent. Or you may even learn a short story about a few horses. It goes like this: some old horses chew apples happily throughout old age. What a nice story about a few horses. Some old horses chew apples happily throughout old age. When we just take the first letter of each of these words, we'll be able to get the same as we see here. SOHCAHTOA. So sine theta is opposite by hypotenuse, cos theta is adjacent by hypotenuse, and tan theta is opposite side by adjacent side. You may have a question whether each of these three ratios are they related to each other. You will be in for a surprise. You will see that tan theta is equal to sine theta by cos theta. Can we check whether sine theta by cos theta equals tan theta? We'll take this value of sine theta by cos theta. What is sine theta by cos theta? Opposite by hypotenuse divided by cos theta is adjacent by hypotenuse. The opposite by hypotenuse I can write like this, multiplied by adjacent by hypotenuse is there in the division. When it is going to multiplication, a by h will become h by a. So hypotenuse side gets cancelled, we'll have O by a, and opposite side by adjacent side is nothing but tan theta. Coming here, this I can write it as tan theta. So sine theta by cos theta is equal to tan theta. What a beautiful relationship that we have between the three trigonometric ratios here. Now what about the remaining three trigonometric ratios? Because in the beginning only we were learning about 6 trigonometric ratios. So what are the three trigonometric ratios that we have not yet learned? So first we'll write the three ratios what we have learned already, which is sine theta O by h, cos theta A by h, tan theta O by a. Now corresponding to each of the trigonometric ratio that we have already have, we'll just take the reciprocal of these values. So sin theta reciprocal is cosecant theta, we'll write like this. So this formula will be h by o. What about cos theta reciprocal? Secant theta, which is h by a, and tan theta reciprocal will be cot theta, which is usually called as cotangent theta, the complete name, where cot theta is the short form of tan theta, where tan is tangent and cot is cotangent, whose reciprocal will be, or its value will be a by o, adjacent side by opposite side. Here are the different trigonometric ratios that we have, and we know here that tan theta equals sin theta by cos theta. So can we say cot theta equals cos theta by sin theta? Yes, of course, they are reciprocals of each other. So we can just simply take the reciprocal of this value to get it as cos theta by sin theta. You may also write cot theta as the reciprocal or the ratio of the remaining two here as cosecant and secant. So 1 by sin theta, which will be called as cosecant theta in the numerator, by cos theta will be taking its reciprocal to the denominator, which is secant theta. So cot theta is equal to cosecant theta by secant theta. So these are the 6 different trigonometric ratios, and some relation I have just given between the ratios itself. So now can we just solve a few of the problems so that we can just get a very clear understanding of this trigonometry chapter. So let us see a few problems where we'll try to get a clear understanding of this chapter. Let us see a first problem. Problem number 1. We have sin A equals to 3 by 4. Find cos A and tan A. So these two values we have to calculate. Whenever one ratio is given, or the ratio of, or the value of one ratio is given, let us just draw a right angle triangle and fill up those values so that we will be able to get to the other values easily. We'll mark PQR. We have given A here, sin A is given, so we have to mark A should be there. Remaining two alphabets, whatever you want, we can take. We'll take it as ABQ. Now angle A, so here is angle A, and we know which is opposite side. BQ is the opposite side, and this side we can take it as 3, and sin A formula is opposite by hypotenuse. So opposite side I have taken as 3, and the hypotenuse side I will be taking it as 4. Now for this right angle triangle we are given two sides and we are not given the side AB. So how are we going to calculate the side AB? It's simple. We are just going to apply Pythagoras theorem. So AB square plus BQ square is equal to AQ square. I need AB square value. So this will be AQ square minus QB square, which is 4 square minus 3 square, giving us 16 minus 9 equals to 7. So the value of AB will be square root of 7. Once we get the three sides of a right angle triangle, we just have to calculate the values of cos A and tan A. So what is cos A? Cos A will be, the formula is adjacent side by hypotenuse. Adjacent side is root 7, so root 7 by hypotenuse side is 4. This is the value of cos A. And what about tan A? Tan A formula, SOHCAHTOA, TOA, opposite by adjacent side. So tan A will be opposite side is 3 by adjacent side is root 7. So the value of cos A is root 7 by 4 adjacent by hypotenuse, and tan A is 3 by root 7 opposite by adjacent side. You see, when we draw a diagram of a right angle triangle by giving the values and applying Pythagoras theorem or whatever the relation that we have to get to all the values, whatever the ratios that are asked, we are able to calculate them very easily. Is that right? Is this problem simple? We'll go to another problem where cot theta is equal to 7 by 8. When cot theta is equal to 7 by 8 given, we just have to find out the value of 1 plus sine theta 1 minus sine theta by 1 plus cos theta 1 minus cos theta. How much is this value? Now how are you going to find out? Now you can also observe cot theta is 7 by 8. You may have a doubt if it is possible for us to calculate this value without using a right angle triangle. It's a very simple process. Cot theta formula is cos theta by sine theta. So cos theta is equal to 7 something. So we'll write it as 7 by k. And sine theta will be equal to 8 by k. So 7 and 8 are adjacent sides and opposite sides of a right angle triangle. And k has to be the hypotenuse. Since k has to be the hypotenuse, we just apply Pythagoras theorem to get the value of k, which is k square is equal to 7 square plus 8 square, 49 plus 64 equal to 113. So k value is equal to square root of 113. So are we getting the value of cos theta and sine theta? Cos theta is 7 by root 113 and sine theta is 8 by root 113. We are just applying the formulae whatever we have learned. Cot theta is cos theta by sine theta. So cos theta is 7 as sine theta is 8. So cos theta is 7 by k. Sine theta is 8 by k. And the adjacent, opposite and the hypotenuse, that you will be able to understand according to what we have done. We are able to get the value of k and hence the values of cos theta and sine theta. Now we have an expression here to find out. You see the numerator 1 plus sine theta 1 minus sine theta. Does it look like a plus b into a minus b, which is a square minus b square? So here in this case 1 square minus sine square theta by denominator also we have got a plus b multiplied by a minus b. And as we learn towards the end of the chapter, we will be able to notice that we can simplify this expression even faster by something called as trigonometric identities. So here the denominator will be 1 square minus cos square theta. Can we calculate the value of this expression? So 1 square is 1 minus sine theta is 8 by root 113. So 8 by root 113, but this is sine square theta. So just take its square on of the given number over here. The denominator will be 1 minus cos square theta. Cos theta is 7 by root 113. So 7 by root 113 the whole square. So this will be 1 minus 8 square is 64 by 113 divided by 1 minus 7 square is 49 by 113. Can we simplify? 113 minus 64 by 113 divided by 113 minus 49 divided by 113, which we can cancel. Both the fractions denominators can be cancelled because both of them are divided by the same number 113. So it's as good as writing them as directly as 113 minus 64 by 113 minus 49, and you'll get the answer as 49 by 64. So the first part of this problem is what we have to calculate this expression, which gives us the answer as 49 by 64. And the other part of the same they are asking as cot square theta, which we can calculate here. Cot square theta equals It's just basically cot theta the whole square. So cot theta value is already given, 7 by 8. So 7 by 8 whole square, which is 49 by 64. And you'll be able to notice that this value is same as cot square theta, which is 49 by 64. Coming up next, we are going to learn about trigonometric ratios of specific angles. Now here in this part, we'll be able to understand that for some values we'll be able to get a very clear expression. For example, if I just have to take the value of sine theta, where theta is equal to 30 degrees, sine of 30 degrees whose value will be equal to half. Now let us see how fast we'll be able to learn all the different trigonometric ratios of special angles. What are the special angles and how are we going to learn them? Let us see here. Let me draw a table of different angles and different trigonometric ratios, so that we'll be able to calculate the values of each of the trigonometric ratios of different angles that we already have here. Let us place the trigonometric ratios over here as sine theta, cos theta and tan theta. Let us find out the trigonometric ratios of some special angles from this table. And you may wonder, where are the reciprocals? We can just simply take the reciprocal of their values at that particular interval. So the angles are 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. Now for all these angles we have some special values of these trigonometric functions. So what are these values? Now we have a simple method to learn. I am just going to explain it to you and you'll be able to get a very clear idea of each of these lines that we have. Now we are just going to learn only for the first line, because the first line we see we have got 5 values. We just take the first 5 whole numbers starting from 0. Whole numbers usually start from 0. So the first 5 whole numbers are 0, 1, 2, 3 and 4. So next step is we just have to find out the largest of all these whole numbers, which is equal to 4. So divide every value by 4 and take the square root of each of these values. This is not any proper method of learning. This is just a simple shortcut that people have found out, that when we calculate all of these we'll be able to get to the values of sine theta. So 0 divided by any number is 0, and root of 1 divided by 4 is equal to half, and this will be square root of half, and here will be root 3 by root of 4 is 2, root of 4 by 4 gets cancelled, and square root of 1 is equal to 1. So these are the values which we can copy it for sine theta. So it's 0, half, 1 by root 2, root 3 by 2 and 1. So root of 1 by 2 is same as 1 by root 2. That is what we'll be usually using it over here. Now what about cos theta? So cos theta is just simply the reverse of sine theta. just take the reverse starting from 1. So we have got 1, we have got root 3 by 2, we have got 1 divided by root 2, we have got half, and we get 0. And what is tan theta? You may already know that it is the ratio of sin theta and cos theta. So 0 by 1 is equal to 0. And when we do the division here, the denominators are the same. So we can just simply take the numerators and do the division, which is 1 by root 3. Both the numbers are same. So here it is 1, and here will be root 3, and here will be undefined. So why tan 90 degree is undefined? Because we do the division here. Any number divided by 0 is very clearly a number which is undefined actually, and this table will help us to get clear idea of whatever the ratios are and their corresponding values at different intervals. We'll look at a few problems on trigonometric ratios of special angles, and we see here whatever the problems are, if we are able to calculate the values, we can do it, and wherever not able to calculate, we cannot do it. Okay, let's see a problem over here. This question says 5 cos square 60 degrees plus 4 secant square 30 degrees minus tan square 45 degrees. Divided by sin square 30 degrees, cos square 30 degrees. Let us see how can we calculate or solve this problem. 5 cos 60. So cos 60 value you can take from the table as half, and since we have got square, we just have to do the square, plus 4. Now secant 30 means it's the reciprocal of cos 30. So cos 30 degree is root 3 by 2, secant 30 degree will be 2 by root 3. And we take the square minus tan square 45 is 1 by sin square 30 plus cos square 30 degrees. How much is sin square 30 degrees? Sin 30 is half. So half square plus cos square 30 degrees. So cos 30 degree is root 3 by 2, and since we have got square, we just have to find out the square of this expression. Can we simplify this further? So here in the numerator, 5 into 1 by 2 whole squares. When we have a square of a fraction, we have to multiply by the numerator and the denominator. So 5 into 1 by 4. We have to take the square of the numerator and the denominator. The same thing we'll do for the next one. So 2 by root 3. So 2 square by root 3 square. 2 square is 4 and root 3 square is 3. Minus 1 here as it is, divided by 1 by 4 plus root 3 by 2. If you take square, we'll get 3 by 4. So calculating, in the numerator we have got 5 by 4 plus 16 by 3 minus 1, and in the denominator 1 by 4 plus 3 by 4. When we just simply add them, the denominators are the same. We add, we'll get 4 by 4, which is equal to 1. So only the numerator we have to concentrate, the LCM being 12. 5 by 4 plus 16 by 3 minus 1. The LCM equals to 12 here only for the numerator, because the denominator becomes 1. When the denominator becomes 1, there is no idea for the denominator values. Okay, so here LCM we calculate it as 12. 4 into 3 is 12, so 5 into 3 will be 15, plus 3 times 4 will be 12, so 16 times 4 will be 64, minus, we don't have any denominator, which means the denominator is equal to 1, so you have to multiply by 12, so multiply by 12 will get 12. Now calculating, 64 plus 15 minus 12 will be 3, 64 plus 3 will be 67 by 12. So if you are very clear with this problem, we can just move on. What about the next problem? The next problem, we have 2 tan 30 degrees by 1 minus tan square 30 degrees. So 2 into tan 30 degrees, you will be able to get it as 1 by root 3. So 2 times 1 by root 3 divided by 1 minus 1 by root 3 the whole square. So denominator we don't have any issues, but sorry, the numerator we don't have any issues, we just have a single expression, so which is 2 by root 3. Denominator we see 1 minus, so this becomes 1/3. Now we simplify, 2 by root 3 divided by, this becomes 3 minus 1 by 3, which is 2 by root 3 divided by 3 minus 1 is 2 by 3. We can write it as two individual fractions, 2 by root 3 multiplied by the reciprocal here will come as 3 by 2, and 2 gets cancelled, 3 by root 3 will be equal to root 3 only, which is approximate value will be 1.73205 and so on. So this is the answer for this problem, 2 tan 30 degrees by 1 minus tan square 30 degrees. Continuing to the last part, we have got something called as trigonometric identities. So identities are some statements where whatever may be the value of the variable you substitute, the value or the answer comes the same. It does not depend upon the variable that we have, but when we just look at the trigonometric identities here, we see the 6 trigonometric ratios: sin theta, cos theta, tan theta, and their corresponding reciprocals respectively, cosecant theta, secant theta, and cot theta. Now, these 6 trigonometric ratios, they are related with each other by some bond, that is what we call as their identities. Now the 3 identities are sin square theta plus cos square theta equals to 1. You can prove this easily. Pythagoras theorem will be of a very big help here, which you can prove it easily. And the second one, you can just remember second and third equations in multiple different ways. Now the second one, you can get it from the first one by dividing by sin square theta or cos square theta. Each of them you will get one equation. So dividing this equation by cos square theta, you will get, so tan square theta plus 1 equals secant square theta, and dividing the first equation by sin square theta, will get 1 plus cot square theta equals cosecant square theta. So these are the basic trigonometric identities that we have, and using these, whatever the problems in the exercise you may be able to solve. We'll just do a few problems before finishing with this chapter. We have a very important problem which you might have seen this question repeatedly. Prove that sin A plus cosecant A whole square plus cos A plus secant A whole square equals 7 plus tan square A plus cot square A. If you want, you can try this problem before looking at the solution. Now here is the solution. In order to prove any of these identities, the best way that we can take is take one side and simplify, and if it is possible you can get to the other side by itself. Otherwise take two separate sides and simplify to get the same answer. Okay, so now I'm going to start from the left hand side. Is it possible for me to reach the right hand side from the left hand side? So I'm just going to take the left hand side as sin A plus cosecant A the whole square plus cos A plus secant A the whole square, and this is what the left hand side that we have. And one more important or one more interesting information about this problem is that you'll be able to see each and every single ratio of trigonometry present here, each present only once in the question. Okay, coming on to the solution here, I've just taken the left hand side expression. So we have this formula A plus B whole square formula. We are going to apply it. A square plus 2AB plus B square. So this gives us sin square A, that is the square of sin A, plus square of cosecant A, that will be cosecant square A, plus 2 into sin A into cosecant A. Now do the same for the next expression here, which also uses the same formula as A plus B whole square equals A square plus 2AB plus B square. So this will be getting cos squared A plus secant squared A plus 2 cos A into secant A. Now you simplify here, you'll be able to observe that sin square A plus cos square A is equal to 1, because that's the first identity that you have learned. Sin square theta plus cos square theta is equal to 1, and we have the remaining expressions. If you want, you can just write them as it is, and let us see. We'll just continue. So we have got cosecant here, so cosecant square A plus secant square A, will just have it as it is, plus 2 into sin A into cosecant A. So sin A cosecant A cancel when you are taking the product. That means when we do the multiplication, whatever required calculations or cancellations are there, we can just simply cancel them like this. So here cos square A plus secant square A plus 2 cos A secant A. Cos A and secant A are reciprocals. When we just try to cancel out the product of the reciprocals, we can just do it here. So we have 2 over here, we have got 2 over here. 2 plus 2 gives us 4. Now 1 plus 4 is 5, and cosecant square A can be written as 1 plus cot square A, and secant square A can be written as 1 plus tan square A. Now 5 here, 1 here gives us 6, and here gives us 1, 6 plus 1, giving us 7 plus cot square A plus tan square A, or 7 plus tan square A plus cot square A, which is the right hand side. I've started from the left hand side expression, did some calculations, and I'm able to arrive at the right hand side expression, which is what we needed to prove. Hence the given statement is proved. Let us see one more problem, a problem where many people get confused, and let us just get to know the idea of how to solve this problem over here. So the question is, we have got cos A minus sin A plus 1 by cos A plus sin A minus 1 equals cosecant A plus cot A. So this is what we have to prove. You have to prove this expression is equal or not. Now when we just look at the left hand side, we have got three terms each in the numerator and the denominator, which we seem to observe that it is a little difficult task for us to do simplification. So let us see how can we do the simplification of this expression over here. We'll take the left hand side. We just have to look at some important aspects before solving the problem. So left hand side we have got cosine and sine. On the right hand side we have got cosecant and cot. Now cosecant and cot here is there. Now how can we change the left hand side to cosecant and cot? So cosecant is 1 by sine and cot is cos theta by sine theta will be cot theta. So you will be able to observe that both of them are the ratios which are obtained when sine theta is divided. So what I am going to do, the left hand side, every term in the numerator and the denominator I am going to divide it by sine A. So the expression looks here like this. So which is cos A by sine A minus sine A by sine A plus 1 by sine A divided by cos A by sine A plus sine A by sine A minus 1 by sine A. Every term in the numerator and the denominator I have divided by sine A. Now let us see how can we do the simplification. What we need to do, we just simplify the expressions here. Cos A by sine A is cot A in the numerator as well as cot A in the denominator, minus sine A cancel will give us 1, and then in the denominator also will be plus 1, and let us see 1 by sine A is cosecant A. Cosecant A in the numerator and cosecant A in the denominator. So we have the expression cot A plus cosecant A minus 1 in the numerator by cot A minus cosecant A plus 1. And we have to prove that this expression is equal to cosecant A plus cot A. Only two terms are there, no fractions. Now, what is the identity between cot and cosecant? So we know cot square theta plus 1 equals cosecant square theta. So instead of 1, I am going to write it as, so the remaining cot A plus cosecant A as it is minus 1, I am going to write it as cosecant square A minus cot square A. Now here the method that we need to use to solve this problem is substitute the 1 at the top, let the 1 at the bottom be as it is. So denominator we are not going to do any change here, so which is cot A minus cosecant A plus 1. Now numerator cot A plus cosecant A minus, now cosecant square A minus cot square A is, which is 1, I am going to write it as cosecant A plus cot A cosecant A minus cot A, which is divided by denominator no change. I am just going to place the denominator as it is, cot A minus cosecant A plus 1. Now what is common in the numerator? When you look at the numerator, you will be able to observe that there are some terms which is common, which is cot A plus cosecant A. When I take this expression common, so I will be left with 1, because you see cosecant A plus cot A is present here, cot A plus cosecant A is present here. So I'm just able to take cot A plus cosecant A common. 1 minus of cosecant A minus cot A. Remember we are having a parenthesis here. So divided by cot A minus cosecant A plus 1. So 1 we have here, 1 we have, minus cosecant A is here, minus of minus cot A plus cot A is over here. So you can simply cancel out these two terms, you see, and that is the reason I have not changed the denominator over here. The denominator remained the same because I am able to get the numerator factorized and one value will be the same as the denominator. Now we are left with cot A plus cosecant A, and this is what we have to prove. This is the right hand side, hence proved. All the other problems in a similar way, when we just learn the identities properly, you will be able to solve them. So you need to have a good practice of the identities. We will be able to get to know very clearly how to solve each of these problems. Alright everyone, we have learnt more on trigonometry, introduction to trigonometry, where we have learnt the basic trigonometric ratios, the trigonometric ratios of special angles, and finally we have learnt about trigonometric identity. So what all we have learnt? So we have learnt about trigonometry as a subject. We learnt about right angled triangles, which we can call them as RAT for short. I hope you are not afraid of rats. There are 6 different trigonometric ratios: sine, cos, tan, cosecant, secant, cot. Just observe the formula as a word like SOHCAHTOA, or the short story that we have learnt about horses. Some old horses chew apples happily throughout old age. You have learnt about the reciprocal ratios as well. You have also learnt about trigonometric ratios of special angles and we have also learned about trigonometric identities. And now we are able to get to a very clear understanding of this trigonometric chapter, introduction to trigonometry. Make sure you practice the problems, the exercises from your textbook. This is one of the chapters where we can score marks easily. The more problems you solve, the more comfortable you become. And here I am just going to add some problems in the next page for you to practice. So you can just go ahead and you can try to solve these problems, which will help you get to know the understanding of this chapter. Trigonometry is one of those chapters where practice truly makes perfect. The more problems you solve, the more comfortable you will become. So let's go through some of the problems over here. So look at some of the problems over here. So these problems will help you to get a clear idea on this chapter of trigonometry, and few more problems you can find out in the next page. So here you are able to see some problems, especially from the identities topic. A few of them may be challenging, but you can get to understand these problems by solving them, by practicing them, by learning these methods from these identities. So if you found this video helpful, please like and subscribe to this channel. Drop your questions in the comments below and I'll be happy to answer them. Stay tuned. In the next video we'll be learning more on mathematics, more topics we'll be learning, more problems we'll be solving, and stay tuned. Thanks for watching and happy learning. Thank you all.